Welcome to Prerana Science PU College. I am Dr. Baswanayas. I am going to take the NEET coaching class for the second PU chemistry for the chapter D and block elements. So this is a very important chapter for the competitive examination. In this chapter, we are going to score good marks. So easily you can get the marks without doubt. Okay. So we will discuss some questions in this chapter. So we'll start. The first question is that one, the bivalent metal ion having maximum paramagnetic behavior among the first transition series of the elements, and manganese, copper, scandium, copper, they are given that. So here, first you have to understand that one, the transition series. What is that one? Transition series, and the first transition series that it means. So what is the first transition series? We call that 3D series. In that, which are the elements are present? Commonly we are using the code that is Sachin Tendulkar was very crazy man, did free coaching to Nikhil Cousin. So here I am writing the cousin spelling CUZN. So here this is the code. If you are remembering that one, so then easily you can write all the elements. Okay. So what is that one? Sachin. Is that one? The name of the first letter we can take the Sachin. Yes. So the first element is scandium, and then next Tendulkar, that is titanium, and then very weak we take that vanadium, and crazy Cr, that is what is that? Chromium, and man, here Mn is there. What is that one? Man, that is manganese, and did free Kochi F. F is what? Fe, iron, and then CO, that is cobalt, and here nickel. Here we have taken that two letters, that is nickel, and then cousin. Here Cu we write, and Zn. See, easily you can write that one. So don't forget this code. So easily you understand that one, and if you know these elements, easily you can answer the many of the questions from this chapter. Okay, so and see that scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Okay, now come to the question. What is that one? Bivalent metal. The bivalent metal ion. What is that bivalent? That is +2 oxidation state. We can call that bivalent. So here metal ion M+2, we can write it generally, having maximum paramagnetic behavior. It is this showing that what is that paramagnetic behavior among the first transition series. Now we have to see that. So already we know that one, the paramagnetism shown by which of the elements? The elements having the unpaired electrons. The elements having the unpaired electrons in d orbitals. So in d orbitals, we have to see that one. So which of the elements having that? These elements given that in the options. In these elements, so which of the ion having the unpaired electron? So first we have to understand that one. How many electrons present in this one? So easily if you know these elements, so first you should concentrate on that. The atomic number of these elements. So it is short from 21 to 30, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay. So here scandium, titanium, vanadium, chromium, these are the elements having that different atomic. So and then how to write that electronic configuration, that is also very, very important for this one. Electronic configuration also you should know. Commonly, how to write that electronic configuration for scandium. So we will take that argon, that is noble gas, having that atomic number 18, that is finished. Next, we will start that 4s2, that is 18 plus 2, 20, then over. Next, how much? After 20, how many electrons are there? 1. So we will write that 3D1. 3D comes and 3D1. So like that. So if you write for titanium, that is 4s2 3D2. Next, vanadium. What is that one? Vanadium for vanadium? That is 4s2 3D3. Chromium 4s2 3D. How much you are writing? 3D4? No. So here you have to change that. It is nearly half weight. 4s1 3D5 you have to write, and then for manganese, what you have to write? 4s2 3D5. Similarly, for iron, 4s2 3D6, and then cobalt, 4s2 3D7. So here you have to be careful that one. So nickel is okay, no problem for this nickel, and here you have to be careful for writing the electronic configuration for copper, that is 4s1, it is 3D10. So commonly you have to write what? You have to write, we will write that 4s2 3D9, but it is near to completely filled d orbital. So then we will write that 3D10 and 4s1. One electron shift from s orbital to d orbital, it is completely filled. And for zinc, 4s2 3D10. This electronic configuration you should not forget. Mn2 plus, that is electronic configuration of right, that is argon, is from D, we write that, and after that, so Mn2 plus, that is we write that 4s0 3D1. Then copper 2 plus, so argon we write 2 plus. 2 electrons from where we are going to remove? So 1 electron from s orbital we will remove, and then another 1 electron from d orbital, we write that 3D9. And then scandium 2 plus. So scandium 2 plus argon, and then so we remove 2 electrons from s orbital, and then so 1 electron is remaining in d orbital, and then copper plus. So here we are, okay, so we are going to discuss this question. The bivalent metal ion having the maximum paramagnetic behavior among the first transition series of the element. Now we have to understand that. So here first we have to write the electronic configuration of these ions. Mn2 plus. So commonly, what is the atomic number of Mn? That is 25. So that is electronic configuration is 4s2 3D5. Now 2 electrons if you are removed, so in d orbital which are the elements? How many elements electrons are there? 5. So Mn2 plus d5 electrons. So that is, you can say that 3D5. And then 4s is 0. You can write as no, if you are not writing also no problem. So Mn, so then Cu2 plus, that is atomic number is 29. So the atomic configuration is how much? 4s1 3D10. 3D10. So now we are removing 2 electrons. Removing 2 electrons from where? From one electron from s orbital and 1 electron from d. So remaining is 3D9 4s0. 4s. Now next scandium 2 plus. Scandium 2 plus. In that scandium what atomic number is 21. 2 electrons removed from s orbital. So 1 electron is removed, is remaining d orbital. Okay. And then copper Cu plus. Cu plus, already you know that one. 2 electrons here removed. So 1 electron has to be removed from the copper. So then we get 3D10 only. Now we see that one. The paramagnetic behavior means in the d orbital must have unpaired electron. So commonly easily see that one. So easy one, this one. Easy one. So ion, the bivalent metal ion having maximum, he is asking that what is the question? Maximum paramagnetic. Okay, so here also unpaired electron, here completely filled. So in this one, completely filled, there is no unpaired electron is there. So then it is not an answer. So then we have to see that in these 3 only we have to check. So here, how many electrons present in d orbital. So d5, commonly we will write that 2, 3, 4, 5. So one electron in each orbital is there. In 3d9, one, two, three, four, five. If you are filling the electrons here, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 more. So only one unpaired electron is there, and in scandium also only one unpaired electron is there. Okay. So here paramagnetic means so more number of electrons present, then it is filled with the maximum paramagnetic behavior. So the answer is which one? It is the answer. Okay. So we will see the next question. Come to that. The next question. The highest value of the calculated spin-only magnetic moment NPM, that is Bohr magneton, among all the transition metal complexes is so 4.92, 3.87, 6.93, and 4.90. So here we know that one. Commonly, the magnetic moment has to be calculated by using the formula mu is equal to square root of n into n plus 2. N into n plus 2. So now what is n? N is equal to presence of number of unpaired electrons in d orbitals only. So d orbitals. So then if n is equal to 1, that is in d orbitals only one electron are there. So then what is the magnetic moment? Mu is equal to 1.73. 1.73. Already we have calculated that one. So n is equal to 2. Then 2 electrons are present. So then D2 that is 2.84. 2.84 and n is equal to 3. That is 3 electrons present in this one, and this is 3.87 and n is equal to 4. So then D4 is how much? 4.90 and n is equal to 5. D5 is 5.92. This has to be calculated, and you should not forget these values. Then easily you can answer the questions until you can go for tricky questions. Okay, so see that one. The highest value of the calculated spin-only magnetic moment among all the transition metal complex means, so in the elements, the unpaired electrons are 5 unpaired electrons present in the d orbitals. So that is the maximum. The maximum unpaired electrons present in the transition elements is 5 only. So then the magnetic moment is 5.92. Then the answer is this one. Okay? Good. Next questions. Next question is, Mn2 plus compounds are more stable than compounds toward oxidations to the +3 stage, because Mn2 plus has all-filled d orbitals, Mn2 plus has off-filled d orbitals, Mn2 plus is bigger in size, Mn2 plus has completely filled d orbitals, Mn2 plus does not exist. This is the answer for this one. If you know the considerations, then easily you can write it. Easily you can answer this one. See this one. Mn2 plus compounds are more stable than compounds towards oxidations into their +3 oxidation state. That means he is telling that Mn2 plus is more stable than Mn3 plus. He is saying that Mn2 plus is more stable than Mn3 plus. Then we have to see the stability of the ions. So see the stability of the ions. So commonly if you write the electronic configuration, easily you can understand. So Mn2 plus. So what is that? The Mn2 plus, how many electrons present in d orbitals? That is d5. d5. So if you write the orbital diagram, if you fill that one, 1, 2, 3, 4, 5, d5. So in Mn3 plus, how many electrons are there? Mn3 plus, that is total atomic number is 25. We are going to remove the 3 electrons. So 2 electrons from S, 1 electron from D. So then, remaining is 4. So that is 3D4 is there. So then, if you are writing, that is only 1, 2, 3, 4. 1 is vector. See that stability. Already we have studied in the first year. So that is first you have studied that all the elements that we have in that electronic configuration having off field and full field are completely stable. So here this is off field. Off field orbital, the orbitals containing, so they are completely stable. So then, we see that one Mn2 plus is off field is stable. Leave about that bigger sense size, it's not that one. Completely filled, no, there is no completely filled because there is no 10 electrons present in that one. Mn2 plus does not exist, so it is existing. Okay, commonly you know that one. Mn2 plus is existing in the many molecules. Okay, so now easily you can ask. So we will go for next one. Which of the following element does not show variable oxidation state? This was asked in the JEE 2019. Very easy one question. Easily you can answer it. And in fraction of seconds you can answer it and then you can go for next question. Which of the following element does not show variable oxidation state? So if you know the oxidation states of the elements, easily you are studying the oxidation elements. So here copper is having that +2 and then +1 oxidation. Titanium also, you know that one. Titanium also showing that +2 to +4 oxidation state. +4 oxidation state. And then scandium, only that +3 oxidation state. But vanadium +2 to +4 +5. It is +2 to +5 oxidation state. Okay, +2 to +5. Okay, so only one which is not having variable oxidation state, that is scandium. Directly within 1 second you can answer it and you can go for next question. Okay. We have highest stable oxidation state of Mn is, that is +6, +4, +7, +3. So that is F is chlorine. Chlorine with manganese, what is the highest oxidation state? Commonly, the highest oxidation state of the chlorine compound with manganese is MnF4. This is the product we are getting, that the MnF4 is the chlorine manganese fluoride compound. We are getting that one. So in that Mn, in this compound, the manganese having the oxidation state +4. So then answer is. So with O means with oxygen, highest stable oxidation state of Mn is. Highest stable oxidation state of Mn is. So Mn, the oxygen forms the compound, you already know that one, MnO4 2 minus or KMnO4. Commonly you know that one, MnO4, KMnO4 or MnO4 minus. MnO4 minus. So MnO4 minus, in that the oxidation state of manganese is +7. So we know that one. So then the alkyl oxidation state is +7. Okay, the A is the answer. These are the easy questions. Easily you can answer it. So next question. Which of the following have highest magnetic moment? Highest magnetic moment. So here highest magnetic moment means, so commonly you should know that N, how much? That is more number, and then that means that how many electrons, unpaired electrons present in the orbital. Okay, you will see this one. So given that options, that is Fe2 plus. Fe2 plus means how much? So the atomic number is 26. 2 electrons is removed from the iron. So that is from the S we are going to remove the 2 electrons, and then the electrons present in D is 6. So then if you write the electronic configuration, so 4, 5 and then 6. Then the total unpaired electrons is 4. So in iron 2 plus, so that is the 4 unpaired electrons are present. So next is manganese. So in manganese, what is the atomic number? Atomic number is 25. So the oxidation state is Mn plus. So Mn plus, one electron has to remove. One electron has to remove from the manganese. So from where we are going to remove? So we are going to remove the electrons from s orbital. So then, so that is 4s1 is there. 3d remaining, that one 5. So then in d orbital 5 electrons are there. So then unpaired electrons are 5. So next, chromium. So atomic number is 24. So 24. Oxidation state is +2. Then the electronic configuration, you have to write there where you have to remove the electrons. 2 electrons from s orbital. So from s we are going to remove the electrons and then 1 electron from the d orbital. So then we are getting 4 is 0, 3d 4. Then the unpaired electrons are 4. Next, here P plus. Here P plus, that is iron, that is 26. The atomic number is 26. So 1 electron has to remove from where? From the s orbital. So then we can write that 4s1 3d6. 4s1 3d6. 3d6, here we are writing 3d6. So then how many electrons? 4. So then 4 unpaired electrons are present. So then, so here asking that highest magnetic moment. So highest unpaired electrons are present in where? In Mn plus. So that is totally 5 unpaired electrons present in other 4 pair. So then answer is second. Okay. Next, the species which is paramagnetic. The species which is paramagnetic. So like that only some many questions they are going to ask. They are very easy one. So just if we know the oxidation state and electronic configuration of these d block elements, so easily you can answer. See that one paramagnetic. That paramagnetic means unpaired electron has to present. So come to that chromium plus Cr plus. The atomic number is how much? Atomic number is 24. Cr plus means 1 electron has to remove 1 electron from s orbital. So then the remaining electrons present in D are 5. Okay. So then here Zn, that is 20. In Zn2 plus. In Zn2 plus how much? In Zn2 plus, this is again Cr3 plus, Cr plus. Zn2 plus, that is 3d. And in Cu plus, that is once again the atomic number is 29. Plus means 1 electron has to remove. 1 electron has to remove from s orbital. So if you are removing 1 electron, we are getting 10. And here we see that one MnO4 minus. This is permanganate ion. This is permanganate ion. So oxidation state. You know that one how to calculate the oxidation state. So then what is the oxidation state of manganese here? +7. So Mn +7. So that is the atomic number is how much of manganese? Atomic number is 25. Then electronic configuration if you write and return, so that is 4s2 3d5. Here the +7 oxidation state, then we are going to remove these totally 5 plus 2, 7 electron. So then, so in Mn plus 7, so there is no electron present in d orbital. The paramagnetic behavior means the element must have the free unpaired electrons in d orbitals. Where the unpaired electron present? In chromium. So then answer is okay. So these are the very easy questions, students. Next, which one of the following pairs of ions have same electronic configuration? Once again similar to that one, same electronic configuration. So oxidation state they are given that one. Now we have to see that one. the electronic configuration. So we will write that the electronic configuration for chromium 3 plus and then Fe 3 plus and then Mn 2 plus and then Fe3 plus is there and then cobalt 3 plus and then scandium 3 plus. So these are the ions. Chromium 3 plus. Atomic number is how much? Atomic number is 24. 24. Now 3 plus means 3 electrons has to remove 1 electron from the s and 2 electrons from the d orbital. So then in the d orbital how many electrons are there? 3d 3. 1 electron from the s orbital and 2 electrons from the d orbital. We have to write 3d3. So next Fe3 plus. Atomic number is 26. 2 electrons from the s orbital, 1 electrons from the d orbital. We are getting 3d5. Next Mn2 plus. Atomic number is 25. So 2 electrons has to remove. So 3d5. And then cobalt 3 plus. Cobalt atomic number is free coach into nickel cousin. Easily you know that one. Cobalt is 27. 3 plus means 2 electrons from the s, 1 electron from the d orbital. We get 3d6. So and then scandium 3 plus. Scandium 21. So 2 electrons from the s, 1 electron from the d. So you get 3d6. Now we see that one. Which are the ions having same electronic configuration? Iron and manganese, where the combination is given iron and manganese. So in the second option, iron and manganese are given. So that is the answer. Okay. Next, the magnetic moment of a transition metal ion is found to be 5.92 Bohr magneton Bm. The number of unpaired electrons present in it. So starting already we discussed that one. 5.92, highest magnetic moment present in the d orbital having the unpaired electrons are 5. Okay, that is if you have forgotten, use square root of n into n plus 2. If you take n is equal to 5, then easily you will get mu is equal to 5.92. Okay, that means the d orbital must have unpaired electron 5. Okay. Next, which one of the following exhibit highest oxidation state? This generally direct questions. So you all studied in the theory, which is having the highest oxidation state. Commonly you know that one. The middle element of the transition series having highest oxidation state. That is which one? Zirconium, vanadium, manganese and nickel. So answer is Mn. The highest oxidation state is yes. Okay. Next. The element which does not show D0 configuration in its highest oxidation state. Just you have to think easily you can answer. D0, that means D orbital, there is no electrons are present. So D0. So then you have to see that one, that is highest oxidation state. First you should know that highest oxidation state. In that case, the element does not have D0 configuration. That means that element must have the electrons in D orbital. Okay. Now see that one, vanadium. What is the oxidation state of this one? +2 to +5. Highest oxidation state is +5. +5. Now you see that one, +5 oxidation state. So what is the atomic number of this one? 23. So 23 means, so after argon, if you write the argon, 18. After that, how many electrons has to write? 5 electrons has to write in 4s2 3d3. So we are going to remove these 5 electrons. So then d orbitals, how many electrons? There is no electrons present. Okay. So then manganese. So commonly you know that manganese highest oxidation state is +7. So +7 means, so atomic number is 25. So then after argon 18. So we are going to fill the electrons in 4s2 3d5. So then totally 7 electrons are there. 7 electrons we are going to remove from the manganese. So then here also D0. And then next chromium. Chromium, you see that one, chromium atomic number is 24. So then electronic configuration is after argon, what is that one? 4s1 3d5. Highest oxidation is how much? Highest oxidation state. So for the chromium, that is, already you know that one, dichromate, potassium dichromate. So +6 oxidation state. You should not forget that one. You see, chromium, if you forget, so you just remember that potassium dichromate. That is +6 oxidation state. So highest oxidation state is +6. So we are going to remove the 6 electron from S1 and D5 electrons. So that is here also D0. And the remaining last one is iron. What is the atomic number of this one? 26. So what is the highest oxidation state of this one? That is highest oxidation state is +6. Highest oxidation state is +6 for this one. Now the electronic configuration is you have to write that one, that is after argon 4s2 3d6. Now +6 oxidation state. +6 oxidation state. First you have to remove the electrons from s orbital to another 4 from this d orbital. So then the remaining the electrons from in d orbitals are how much? That is 2, 3. So then we are asking that the element which does not show D0 configuration is highest oxidation state, that is iron. Okay, this is the correct. So that another question. The ammonium dichromate is used in fireworks. So the green color powder blown in the air is, that is the ammonium dichromate. NH4 twice Cr2O. So this undergo converting into hot. So the formation of Cr2O3 plus N2 plus O2. This is the reaction taking place. So in the fireworks, so ammonium dichromate converting into Cr2O3 into 4H2O. If you are not knowing this equation also, easily you can answer by seeing the products. So what is that one is that, so in ammonium dichromate, the chromium is present in +6 oxidation state. And you know that one, the green colored powder is formed. So green color, commonly chromium in +6 oxidation state is using orange color. Where you have seen this +6 oxidation state, so that is dichromate. Here is given that one dichromate. That is potassium dichromate. K2Cr2O7. So you are using the laboratory. So in the salt analysis and all, so K2Cr2O7, that is orange color. Okay. So then here there is that green color. So here +6 oxidation state is there in the dichromate. It is converting into green color. So you should not forget that one. That is, so green color, the chromium it is present in +3 oxidation state. So it is that one +3 oxidation state, that is green color. So then you see that one +3 oxidation state in this examples. So that is the chromium, that is here +2, and here that is Cr2O3. What is that one? That is +3, and here 0, and here is +6. So where is that one? +3. That is green color powder is formed, and the second one is okay. So okay. So we discuss next question. What is the oxidation state of chromium in dichromate? That is +6 oxidation state. So if you see this one +6 oxidation state of chromium, that is d electrons are how much? How much d electrons are present? There 0. Because +6 oxidation state, the totally the presence of 6 electrons we are going to remove. So then there is no electrons, unpaired electrons present in d orbital. So then already you know that one commonly what you are studied in theory, That is, we have studied in theory that when the unpaired electrons present in the d orbitals, then they are showing the color. So here there is no electrons present, but even though it is showing that orange color. Why it is showing that one? Because of charge transfer spectra. We call that charge transfer spectra. So what is that one? Charge transfer. So we call that charge transfer spectra. That is from where? So from ligand to metal. Ligand to metal. So metal is having that +6 oxidation state. There is no electrons is present in that one. But ligand donates the electrons. Okay, ligand donates the electrons and formation of the complexes. So here we call that LM spectra. We also call that LM charge spectra. So here we are saying that one LM spectra, that is charge transfer spectra, that is ligand to metal charge transfer. So that is because of this reason. So this dichromate showing that color. And next FeSO4 or Fe+2 showing the color. Why it is showing that one? So Fe2 plus means how many electrons are present in the d orbitals? We are removing the 2 electrons from the S and then another 6 electrons present in the D. So here the 6 electrons present in the D means, so how many unpaired electrons are present? How many unpaired electrons? 5, 6. That is the 4 unpaired electrons. 4 unpaired electrons. In that 4 unpaired electrons are present. So these 4 electrons are responsible for the color. So what they will do? They undergo DD transition. So DD transition. So this is according to UBT we are writing that one. So commonly already we are studying that one on crystal field theory. In the crystal field theory, what happens? So these d orbitals undergo splitting into T2G and EG. So there the electrons present from T2G to jumps from T2G to EG. So then there is a DD transition taken place. So then because of that reason, so these are showing that color. Color means it is visible reason they are going to absorb the light reason. So and then complementary color they are showing. So because of that reason. Now the sentences, the options are given that one. That is potassium dichromate and Fe2 plus ions are respectively due to. So what is that one? Potassium dichromate is DD transition and Fe2 plus is charge transfer from. So potassium dichromate charge transfer and Fe2 plus DD. Okay, right. Next, crystal defects and charge transfer spectra. There is no crystal defects and all. So crystal defects commonly you are studying that one in the solid state because of the defect in the crystals, the formation of F centers. So this is not possible here. And then charge transfer spectra and crystal defects not possible. Okay. So here the only one. This one is the answer. Okay. Understand the point? So we go for next question. CrO3 is colored due to. Once again, that is another one related to color only. They are D block elements. So the CrO3. So CrO3 is colored due to. So what is the options? First you have to see the options. So immediately you can answer it. Crystal defect, unpaired electron, charge transfer spectra, and low ionization energy. So now we see that CrO3. What is the oxidation state of chromium here? Oxidation state of chromium, that is +6. Oxidation state of chromium is +6. So then the electrons are there. Electrons, unpaired electrons present here? No. There is no unpaired electrons. There is no unpaired electrons. There is no unpaired electrons. So then, what is the answer? There is no crystal defect. Commonly we call that one in the transition elements. Unpaired electrons is not possible, and there is no unpaired electrons present. So and then charge transfer spectra. So last question we discussed that one. So then this is the answer. That is the charge transfer spectra. Because of that reason, so this is showing the. Okay. Next question. Which of the following ions will exhibit color in aqueous solutions? Which of the following ions exhibits color? See that. So lanthanum ions, titanium ion, lutetium ion, scandium ion. So then atomic numbers also given that. Easily commonly you studied that lanthanides. So lanthanide is situated in +3 oxidation state. What is that one? Lanthanide, that is atomic number is 57. So we already know that one electronic configuration of lanthanide. Xenon, after xenon 54, we are going to write the fill the electrons in the which one? Where we are going to fill the electrons? So we are going to fill the electrons in the next d orbitals, and then s orbitals. So that is 5d1, 5d1, 4s. Sorry. Correct? 5d1, 4s, 4s, 2, no 4s. Next question. Which of the following ions will exhibit color in aqueous solution? Lanthanum 3+, titanium 3+, lutetium 3+, and scandium 3+. Atomic numbers also given. So if you take on the lanthanides, so that is lanthanum 3+, that is oxidation state. If you are writing that one, so lanthanide, that is xenon 54, we will write that. After that, 3 plus means 3 electrons is removed. 3 electrons is removed. So 3 electrons removed from 5d1 and 6s2. So 2 electrons from 6s2 and then 1 electrons from 5d1. So we are removing that one. That is, if you are not knowing that easily, you can write it. So 5d1, 6s2. So that is the lanthanum oxidation state. Electronic configuration, that is N +3 oxidation state. We are going to remove this. Then we will get xenon 54 and then 5d. Okay, so then there is no electrons present in d orbital here. Next, titanium 3+. What is the atomic number of titanium? That is, titanium is 22. So in that 22, so we are going to remove the 3 electrons. So then 2 electrons from the s orbital, 1 electron from the d orbital. So how much will remain in the d orbitals? That is 3d1. So 3d1 is there. So next, lutetium 3+, atomic number is 71. So after xenon, we are going to write that one. Xenon 54, and then so lutetium, if we are writing lutetium 54, so that is 4f14, 5d1, 6s2. This is the electronic configuration of lutetium. In +3 oxidation state, we are going to remove the 3 electrons, 1 from T and 2 from S. So that is okay. Next, scandium 3+ means 21, already know that one. So 21 means, so 3 electrons we are going to remove, 2 from S and 1 from D. So then 3D 0. So here, see that one? It has to show color. Color means, so then the D electron must be there. Okay, so D electrons. So where the D electrons are present, see here also lanthanum 0, titanium 3d1, and then lutetium 0, and then scandium 0. So then in titanium there is 1 electron is there. Then this is the case. Okay, understand that? Go for next. So which one of the following ions has electronic configuration argon 3d6? So here some of the ions are given, that one Ni3+. So electronic configuration you should write. Nickel, how much? The atomic number? Atomic number is 28. So nickel is 28. So then 3 electrons has to remove. 2 electrons from the S, 1 electron from the D. So then 3d7. Okay. So next, Mn3+. Atomic number is 25. 2 electrons removed from S, 1 electron from D. So then in 3d orbitals there are 4 electrons. Okay. Next, Fe3+. How many electrons are present in the d orbital here in Fe3+? Atomic number is 26. 2 electrons removed from S orbital, 1 electron from D. So then 3d5. Remaining is 5 electrons present in d orbitals. Next, cobalt Cobalt 3 plus. Cobalt 3 plus. So atomic number is how much? 27. Very good. So 27. So here 3 electrons has to remove, 2 electrons from S, 1 electron from T. So then remaining is 3d6. Where is that one questions? The electronic configuration is argon 3d6. Argon after argon 3d6 is there. So then option is correct. Okay. Okay. Go for next. The catalytic activity of transition metals and their compounds is described mainly to that is catalytic activity of transition metals. This is a direct question, so many times you are answered in the theory examinations and all. So very direct question this one. So see that one, catalytic activity shown by transition metals because of that. So here the options are given, their magnetic behavior, note, their unfilled d orbitals, it is related to that one, but it's not an exact answer. Their ability to adopt variable oxidation state, as this one is there, and then their chemical reactivity, not. So it is showing the catalytic activity, it is because of their variable oxidation state. You know that one, the different, for example, if you take a manganese, it is from +2 to +7, and then titanium +2 to +4. So like that, so different oxidation states, variable, called variable oxidation states. So because of that reason, so these showing that catalytic activity. Go for next. So which ion is colorless? It is similar to that one. Which ion is colorless? That means the unpaired electrons present in the d orbital that shows colors. So which is not having unpaired electron, that is colorless. Okay, this is the chromium 4 plus. Chromium 4 plus. So electronic configuration, if you write, so 4 plus, that is that one. So here 4 plus, that is atomic number is 24. So 4 electrons has to remove 2 from S and 2 from S are what? You have forgotten that one. Okay, so you have to remove 1 electron from. So you have forgotten, see that one? Chromium 24, that is 3d5, 4s1. Okay, this is the electronic configuration. Okay, don't forget it. So 3d5, 4s1. So how many electrons you have to remove? 4 electrons. 4 electrons means 1 from S and 3 from this D. So then remaining how much? So 3, 1, 4. So then 3d2. Okay, so then it is 2 electrons are, this is color 1. Next, scandium 3 plus. Scandium. So 21 atomic number 3 plus, 2 from S, 1 from D. So then 3d0. Then it may be the answer. But if it is answer also, so you should see other options also once. So then third one is titanium 3 plus. So titanium 3 plus, the electronic configuration if you are written, so what is the atomic number? Titanium, that is 23. So 23. So you are going to 23. Is it 22? Okay. So 22. Atomic number is 22. You are going to remove the 3 electrons, 2 electrons from S and 1 electrons from D. So then, so in D orbital how many electrons are there? Only 1. So on that, vanadium 3 plus. Vanadium 3 plus, that is, so the atomic number is 23. So 2 electrons from S orbital and 1 from D orbital. So then 2. So then this is the color, it is showing color, it is showing color. So then it is not showing color. So then scandium is the answer. Okay? Understand? Come to next question. Which one of the elements with the following outer orbital configuration may exhibit the largest number of oxidation states? That means what is that one? Exhibit larger number of oxidation states. So here some electronic configuration is given, that one. In that we have to see that one, the largest oxidation shown by any one of the elements. So then we have to remove the electron and then you see the oxidation state. So in A option, so 3d5 4s1, if you remove the electrons, so 6 electrons, the oxidation state is +6. Then here in the B option, so 5 plus 2 you are removing, so then we are getting +7. And in C option, you are going to remove 2 plus 2 or 2 plus 2, totally 4 oxidation state. And in D, 3 plus 2, 5. So here +7 is the highest oxidation state. So then answer is B. Very easy question. Next. Which of the following compound is expected to be color? So generally somewhat is easy one also, but you should be careful while seeing these questions. Okay, so Ag2SO4, CuF2, MgF2, CuCl. Okay, so here Ag2SO4, what is the oxidation state of Ag is +1 here, Ag plus, and then here Cu +2, B option Cu +2, and MgF2 here also Mg +2, and CuCl, what is that one? Oxidation state Cu plus. So expected to be colored. Commonly you know that one. So Ag plus, what is the series come in the group? It is coming that one. It is coming in the group that is copper, silver, gold is coming here. So it is having the same electronic configurations. Okay, so in plus configuration, Ag plus and then Cu plus. So both are having the same type of configuration. That is in the d orbital. So that is D10 is there. That is in plus oxidation state, and this is also in plus oxidation state. 1 plus 1 oxidation state. That is D10. Then this is not showing the color, and it is also not showing color. Next come to that Mg2 plus. Commonly know that one in Mg, that is, so Mg it is not having d orbital. It is not having d orbitals. So then it is old orbital. It is not also showing. So then remaining which one? That is this one, Cu plus 2. So 2 electrons removed. So then what is the electron configuration? 3d9. So it is having that unpaired electron in d orbital. So because of that reason, it is showing. Okay, good. So go for next. Of the ions Zn2 plus, nickel 2 plus, and chromium 3 plus, atomic numbers as 1. Only Zn2 plus is colorless, and nickel 2 plus and chromium 3 plus are colored. All three are colorless. All three are colored. Only nickel 2 plus is colored, and Zn2 plus and Cr2 plus are colorless. See here. So it is related to color also. Okay. So then you have to see that once again. That is the electrons present in d orbitals. That is unpaired electrons. You should see that one. Zn2 plus. Come again that one. Zn2 plus. The 3d10 nickel 2 plus, nickel 2 plus, how much? Nickel 2 plus, so atomic number is 28, 2 electrons is removed, so then 3d8. And chromium 3 plus, how much? Chromium, that is atomic number is 24, 2 electrons from? 2 electrons from? No, 1 electron from S and another 2 from D. 2 electrons from D orbital. So then the remaining electron in D is 3. So zinc, nickel and chromium is the one. See that one. So here unpaired electrons are there. Here unpaired electrons are there. Unpaired electron, you know that one, D8. So if you write the orbital diagram, you easily can write. Understand that. That is 1, 2, 3, 4, 5, 6, 7, 8. 2 unpaired electrons. So here 3 unpaired. Then both are showing color. So here there is no unpaired electron. It is not showing color. That means only Zn2 plus is colorless and both are colored, then it's colorless. Okay, so all are three colorless, wrong. All three are colored, wrong. Only nickel 2 plus. Okay, so then first one is colorless. Okay. Next, the number of unpaired electrons in a nickel atom or atomic number is 28. That is the number plus one. The number of unpaired electron is easy one. Now only they will discuss that one. So here not only nickel atom is given, but they are not given in oxidation state. So easy one. Nickel electronic configuration 28. So after argon, what is that? 4s2 3d, here 20, 18 plus 2, 20 over. So next remaining 8 you have to. So then unpaired electron 1, 2, 3, 4, 5, 6, 7, 8. So how many unpaired electron? 2. That is the answer. Okay. Next, which of the following configuration is correct for iron? Iron electron configuration. This is direct question. Very easy. Simply you can write it. One. Which one? Yes, you are right. So next question is the manganate and permanganate ions are tetrahedral due to the pi bonding involves overlap of p orbitals of oxygen with d orbitals of manganese. There is no pi bonding. The pi bonding involves overlap of p orbitals of oxygen with p orbitals of manganese. That is, they are asking about the bonding between the oxygen and manganese. Now we see the structure of permanganate and manganate. So here the manganate, you know that one MnO4 2 minus. So then, so this you have to write 4 oxygen has to attach to manganese and 2 minus. And 2 oxygen atoms charge you are writing, and then other 2 are balancing by pi bond. And then permanganate MnO4 minus, that is from the KMnO4 easily you can write it. So the structure of this one is MnO4, 4 oxygen, first you write it, and then 1 minus 1 oxygen, and others write it a pi bond. See that there is a formation of bonding between oxygen and manganese. So here the oxygen having the p orbitals, oxygen having p orbitals, and manganese having d orbitals. So that both overlapping, both undergo overlapping and formation of the pi bond. Both formation and the overlapping and formation of pi bond. So then here the answer is the pi bonding was overlapping of p orbitals of oxygen with d orbitals of manganese. So and no pi bonding, and pi bonding was overlap of p orbitals of oxygen with p orbitals of manganese. See that one, p orbitals of manganese. There is no p orbitals of manganese involving, and here also there is no d orbitals of oxygen. Okay, thank you.